This is Mark Boney. Today's date is 24 February 2024. The class is FTT 101 Mechanics and Firearms. Week 2, Module 2 Understanding of Simple Machines. Today we're going to look at, for part 1, the inclined plane. You see those all around as far as like ramps on trailers, ramps on trucks for moving trucks. People use those ramps to load trailers and trucks. A different method that is being used for loading um, trucks with ramps is they use a mechanical, either hydraulic or electric powered um, lift system. And that entails the gate being lowered by power to the ground, placing the product on it, and then using the switch to raise it up to load the truck. Some trailers for loading equipment or anything with wheels and axles. They use ramps, but they can also use winches to help with that, to aid in that. So there are other options out there to take place of the ramps or combine with the ramps and the inclined plane to ease the process of loading and unloading trailers and trucks. Part 2 of this is the understanding of actually how simple machines work. Now, one I could use would be an example would be my lever on my reloading press over there, in the fact that it's got the lever and the fulcrum to lift the arm up to aid in applying primers, sizing cases, or whatnot. So the way that works is a lever on a fulcrum will help you raise a 50-pound block. If you put a lever that's a piece of wood that's like 4 foot long, and no, this is not 4 foot, and you take the fulcrum point, you put it halfway between both ends, which we put it at the 2 foot mark. You put a 50-pound block on one end, it's going to take 50 pounds of force to lift it. If you take that block, that fulcrum, and you take the distance from the middle, which was 2 foot from this end, so you take and you divide that 2 foot into 1 foot, that puts it halfway down, which puts it closer to the product. Now, instead of needing 50 pounds to lift it, you only need 25 pounds of force to lift the product. So it cuts it down in half, cuts down the force needed in half. If you take pulleys, we'll use pulleys as well for this. And if you're using one pulley to raise a block off the ground that weighs 50 pounds, it's going to take you 50 pounds of force to raise it, equal amounts. You can cut that down to 50% needed, which would require the force to be only 25 pounds. So you don't have to pull as hard to raise a 50-pound block by adding 2 pulleys. And then if you added another pulley, a third pulley, again, you would drop that down. So instead of 25 pounds of force, you're going to need 12.5 pounds of force, and so forth. Um, just like with the lever, the longer you can get the effort arm out there, the easier it is going to be to lift the product up. Um, Less force. But in doing so, you can have too much effort arm to where it's just not feasible to do. And then with the pulleys as well, you can have it to where you've got too much rope to go through all the pulleys in order to lift something up, just to make it a little bit easier. So there is a point that you don't want to go too far just to make it easier, but you want to go where it's comfortable. You want to have enough there that it gets the job done, doesn't require as much effort to do the job as it would without, well, with just one. We'll use pulleys, just one pulley. So it would be easier with two pulleys, maybe three, but any more than that, you're looking at too much of a hassle just to reduce that force weight needed. So if you take two pulleys, 50-pound block, 25 pounds of thrust to lift, 25 pounds of not thrust, but 25 pounds of force. You have to pull down 25 pounds to lift 50 pounds with two pulleys, and so forth with the lever. You divide the fulcrum point, move it closer to the object, 50-pound block. If you got it set at 2 foot from the end and you move it in a foot, 25 pounds force needed on the effort arm side, push down in order to lift it up off the ground. That's all I've got. Thank you for your time.